So hello and welcome. It's the chemistry tutor here, Dr. Jones, and I promised you a really difficult molarity calculation, and I've devised this little beast here. Now the reason that this question is so difficult is because it covers the topic of dilution. Now dilution is something that you will probably be getting into around the time that you go to college, or around the time that you go to university here in the UK, and it's the more practical side of molarity calculations. It kind of takes it to the next level. Now what I want to do is I want to show you some of the equipment that you might use when you're performing a dilution in the lab. Now if you're taking an amount of liquid from one beaker and transferring it to another, you're probably going to use, or you will be using, a glass pipette. Here are some glass pipettes here. Now to suck up the liquid, or to suck up the water into the glass pipettes, you either use these balloon devices here. You can see a guy attempting to use them over here. I mean, when you get into the lab, they'll show you how to use things like this. Or you can use these little devices here. Now if you're in a biological lab and you're using very small volumes, say 1 milliliter up to about 50, normally in biological labs you'll use this type of pipette, which is known as a Gilson pipette. I just wanted to introduce you to different types of pipettes, something that you might come across if you do a summer-based lab project. Okay, so let's go on to the next slide. Heidi ho, let's go. Now whenever you get a really difficult moles problem, whether it's molarity or any other type of problem, if I was you, I would draw it out, because by drawing it out it resolves itself in your mind and your head is clear to go on and answer the question. So if we look at the key things within this question, a student dissolves 44 grams of this compound here, sodium chloride, that's common salt, in a beaker containing 72 milliliters of water, so that's beaker number 1. The student then pipettes or removes 1 milliliter of this solution into a new beaker or a second beaker, to which they add 9 milliliters of water. So the question is asking what similarity in the first beaker and what similarity in the second. So let's draw this out. Here we have 44 grams of salt, NaCl, sodium chloride, and we're going to add that to the beaker. We're then going to add 72 milliliters of water, and we're going to give it a stir. So the concentration of beaker 1 is 44 grams in 72 milliliters of water. Then what we do is, once this is thoroughly mixed up, we're going to take 1 milliliter out of this beaker and we're going to put it in beaker number 2. And then what we're going to do is we're going to add 9 milliliters, that's 9 milliliters of water. So we're going to have a new concentration here in beaker number 2. So the total volume in beaker number 2 is going to be, let's have a look at this here. We've got 1 milliliter plus 9 milliliters equals 10 milliliters. So the total volume is 10 milliliters in beaker number 2. So when you first of all get a really complicated question, draw it out. Now, a student dissolves 44 grams of sodium chloride. we're not actually given an amount in moles, which is what we need to answer this question. We're looking for for molarity, so it's an amount of moles in 1 litre. So the first thing we have to do is we have to convert grams into moles. Now, how do we go about doing that? Well, what we do is we look up in the periodic table the relative atomic mass for sodium and the relative atomic mass for chlorine. So we've got, in sodium chloride, we've got 1 atom of sodium and 1 atom of chlorine. So the molecular mass of sodium chloride is 23 grams, you get the 23 from here, and the 35 grams of chlorine from here. Gives you a total of 58 grams. Now we say the molecular mass equals 58 grams. We also say that the mass of 1 mole of sodium chloride is 58 grams. So what we're going to do is we're going to start working through this calculation here. Now we know we have 44 grams in 72 milliliters of water. We're talking about beaker 1 here. So that's 44 grams in 72 milliliters. But we want a molar amount, a molar concentration. How many grams would we have if we had 1 litre? We want a molarity, an amount of moles per litre. So what we do here is we need to calculate the amount of moles in the amount of grams in 1 litre. So if we use this conversion factor here, what this is telling us is how much bigger is 1000 milliliters by 72 milliliters. Now we times that by the amount of grams we've got, and this gives us the total amount of grams we've got in 1000 milliliters. Now we know that 1 mole equals 58 grams of sodium chloride. We have 611 grams in 1000 milliliters. So how many moles are we going to have? Well, if 1 mole is 58 and we've got 611 grams, we're going to have a lot of moles. How many moles are we going to have? We're going to have a lot. If we do the conversion factor here, if we do 611 grams divided by 58, that will give us 10.5 moles. We've got 10.5 moles in 1 litre. So the molarity of the first beaker is 10.5 molar. 10.5 molar. So now what we need to do is we need to progress on to beaker number 2. So beaker number 2. We know beaker number 1 has 611 grams in 1000 milliliters. Now we took 1 milliliter of this solution out of beaker number 1 to add to beaker number 2. So if we've got 611 grams equals 1000 milliliters, how many grams do we have in 1 milliliter? Now we can see it's going to be 1000 times less. So what we could have done is we could have divided 611 by 1000, or we could use this conversion factor here, which is 1 milliliter. Sorry, I'll just go back, you can't see, which is 1 milliliter divided by 1000 times by 611. So we know we've got 0.61 grams in 1 milliliter. Now we know we've got 0.61 grams in 1 milliliter of water. Now to that 1 milliliter we added 9 milliliters of water. We diluted with 9 milliliters of water. So we've got 0.61 grams in a total volume of 10 milliliters. Now in calculations with dilutions, most students fall down at this point. This is the point that really gets them. And I've got this little diagram over here to show you. It doesn't matter that we've added 9 milliliters. and we've got 0.61 grams in 1 milliliter, we've still got 0.61 grams in 10 milliliters. Now let me show you why. Now imagine this is the concentrated solution. I'm going to write 5 little dots. No, actually that's like 1, 2, 3, 4, 5, 6. There's 7. We've got, say, 7. Let's call this atoms. We've got 7 atoms in this volume here. 1 milliliter. That's 1 milliliter. I'm just going to use atoms for now. So we've got 7 atoms in 1 milliliter. And to this we add 9 milliliters. So our total volume goes up to 10 milliliters. But if you imagine the amount of, say, atoms, 2, 3, 4, 5, 6, 7, the amount of atoms hasn't changed, but the concentration, the amount per volume, is lower. Now that is quite a difficult concept to grasp, and it takes people quite a while, but it's just something I wanted to go over in this lecture. So getting back to the question here, we know we've got 0.61 grams in 10 milliliters. So how many grams do we have in 1,000 milliliters? Now we could have times this by 100, because the difference between 10 and 1,000 is 100, so we could have done 100 times 0.61 grams. But if we do this upscale factor here, how much bigger is 1,000 than 10 mils? 1,000 divided by 10 mils times by the amount in grams, 0.61 grams, equals 61 grams per litre. So 1 mole of sodium, we know we've got 61 grams in 1 litre in beaker 2. This is beaker 2. Beaker 2. We know we've got 61 grams per litre. So we know 1 mole of sodium chloride equals 58 grams. Now, if 1 mole equals 58 grams and we have 61 grams, we know we've got approximately a mole, approximately 1 mole. But if we do the calculation, 61 grams divided by 58 grams per mole, we can see here we've got 1.05 moles. So we've got 1.05 moles in 1,000 mils. That's 1.50 moles, because 1,000 mils is 1,000 litres. Sorry, 1,000 mils is 1 litre. 1,000 mils is 1 litre. So the molarity M is 1.05 moles in 1 litre, or we can say 1.05 molar. So that's beaker 2. Beaker 2, that's the answer. Now this is an exceptionally difficult molarity question, and hopefully something like this won't come up in one of your exams. I just wanted to show you a realistic example that you will see in any lab when you go into a lab. If you have covered dilution, hopefully this has been some help. Now if you're struggling with this, please leave a comment below and I'll try and answer you the best I can as soon as I can. I've also done some other simpler questions, simpler molarity questions. I'll put a link to those down below and also a link at the end of this video that you can click on. I hope this has been helpful for you. This has been Dr. Jones. Please take care of yourself. See you soon with more chemistry practice problems. See you soon. Bye.